right. Thanks, Nikolai, for that great demo. It really shows us both the power and simplicity of Iceberg topics and making the stream to table problem basically a push button affair. I like to think of it as ETL by Terraform in the sense that you could just set a single topic property, which you can declaratively do via Terraform and Redpanda Cloud. Just decorate your topic with this one additional property and your lakehouse ingestion problem is basically solved. And as you can see, we've solved the problem robustly where you get this high fidelity, high performing bronze layer in your lakehouse, but still use a single CRUD lifecycle because, as the last session was titled, the topic is the table. So Redpanda, we've been hard at work on this for over 18 months, and it's really become a cornerstone of our platform. But now I'd like to welcome some folks to the stage whose Iceberg journey has been a lot longer than that, so we can step back and take a wider view and discuss some of the impacts that Iceberg is having more broadly on the data platform space, the whole industry really, and how people work with data. Each of these folks is incidentally also a partner of Redpanda who's been working closely with us as we've brought Iceberg topics from concept into production. So let's introduce our panel. First, we'll start with Will Martin, who is an evangelist at Dremio. Welcome, Will.
Hello.
We've also got Stephen Wu with us from Snowflake, who's a software engineer at Snowflake and also a PMC member in the Apache Iceberg project. Welcome, Stephen.
Hi, everyone.
And then we've got Melvyn Peignon, who's joining us from ClickHouse, who's a principal product manager at ClickHouse, focused on the core database and a lot of the Iceberg features that ClickHouse is adding, which I'm sure we'll hear more about. Welcome, Melvyn.
Hey, everybody.
And then last but not least, Mr. Jason Reid, Director of Product Management at Databricks. And he is also a close partner of ours as well as we built Iceberg topics. Welcome, Jason.
Thanks, Matt. Happy to be here.
All right, let's get started. We're going to start with you, Jason, actually. You were kind of like, I'd like to think, patient zero, like probably the first real end user to be subjected to Iceberg, and in fact, to get the power of Iceberg in your hands as kind of the internal customer of the engineers building out this system at Netflix, where the technology was kind of first envisioned and built, and it became very, very successful, as you often say, through this happy accident, solving some practical problems specific to Netflix's data platform, but turning into this lingua franca of the entire data platform space that's used by so many organizations now. So that's pretty exciting, obviously, but therefore you've had the experience, most experience in understanding how teams work with Iceberg, how it changes their daily work and their interaction. Does it add additional actors into the collaboration around data? So in general, how do you think Iceberg has changed the way that data teams, machine learning, AI engineers, and also business analysts, the end consumers of the data, collaborate together?
Yeah, it's a great question, and I've seen the impact of this firsthand, obviously at Netflix, and I get to see it across a larger swath of companies and across our customer base, which is really exciting to see ultimately. I'd actually add another persona into that mix. We sort of saw a bit of the flavor of this in the demo, which is the application engineers, like the folks who are ultimately stream producers, data producers, in the origination of the data. Where historically there's a pretty thick wall between, hey, I'm an application or product engineer, and I only really care about the data model that goes into my transactional system, the one that's powering my application, my service. And whatever else happens then, the analytics side of the world is completely black box to me. And we had all these ETLs, right? And we did all this transformation work. That was the core work of data engineering. And now we see, right, there's this blend where you produce a topic of data which you might be using for your application space, and it also becomes the foundation immediately for your analytics space, right? It becomes the bronze layer of your analytic table. So all of a sudden, those product and application engineers are also brought directly into the world of how their data is actually being used. They should care how their data is being used downstream. It's important. It also hopefully leads to less breakages when product engineers change something and then all of our dashboards break, which is was the case before we had this world where things were more connected. So that's already that's a part of how things change. I think certainly we saw in the demo as well, right? You've got your analysts who are using data warehouse and very classic SQL interfaces, right? And then you also have maybe your data engineers, data scientists coming from Python notebooks or running big jobs with things like Spark. Those are also pretty different worlds historically, right? It was very common before Iceberg to have your data lake, where that's where your ML engineers focus on. They run their Spark jobs, they run their Python jobs on the lake. Then you had some sort of ETL and transformations and copies of data loaded into your warehouse, and that's where your analysts and everything live, right? We've also sort of collapsed those concepts, and so now you've got all parties are working on the same foundational data sets. And look, the value of data, the big value of data, especially in the analytics space, is connecting it, right? Connecting data from across your business, different applications, both first party and third party. And when we can bring it all together in a single format and let all the different tools work against it, everything's much more connected in your business. So, insights you do from your analytics can easily be, put back into your applications or put into your ML models without having to do a lot of like re-engineering or copies of data into another system. The last big thing I see that, sort of brought a new persona into this world is really, I think it unlocks the analysts to be much more effective, like doing that last mile, what is the last mile ETL or last mile data transformations, right? Historically, if they needed a new table or a new metric, especially for anything at scale, it has to go to the data engineering team and build Spark pipelines. But the ability to operate, on these tables with basic SQL and have, big distributed engines process that stuff and have it, you get the safe SQL semantics. You don't necessarily need a data engineer in the mix to worry about exactly how to optimize Parquet files and partitions and all these nuance. Those are things that the platform can just take care of. So getting analysts, the ability to self-serve, I think, is also a big part of it. So that's, a big productivity unlock that I've seen, as Iceberg has been adopted across the ecosystem.
Got it. Anybody else want to weigh in on that question? On the collaboration aspects?
Yeah, I think some of the features like Iceberg have, like versioning, branching, time travel, isolation, they just allow those teams to operate independently, but also together harmoniously, right? They're not going to step on each other's toe. So that's kind of the cool thing to enable them to collaborate much better compared to the previous with Hive. There's a lot of kind of the minds that we may kind of affect each other. Like data producer, they did a partial right and causing the problem for the readers. All those kind of issues are solved by the Iceberg.
Right. Same thing on the ClickHouse side. Like I think it's very interesting for us. Like we have our own native formats at ClickHouse, and having like a strong, I would say, open source format that we can use for federation of data with like data that are residing in ClickHouse is also very important for us. So very happy with all the improvement and progress we've seen in that space.
Yeah, it's about bringing people together without having them step on each other, clearly. That's a good segue into the next question. You mentioned branching, Stephen, and I know Dremio, for example, was pretty early in this space in introducing that concept into their Iceberg catalog. They were generally a pioneer in the Iceberg REST catalog space, I would say. Some of the early tech that we use to test out our work in the Iceberg space was based on the Nessie catalog, which has now been merged with Polaris. So let's switch to Will and kick off this next question, which is more about less the people and more like the technology silos, right? So there's also this sort of technology silo between the operational data estate, the sort of real-time data estate, your Redpanda, Kafka kind of infrastructure, or other sort of real-time messaging infrastructure, and the analytical data estate, which is sort of occupied by lakehouses and traditional data warehouses. And how does Iceberg enable us to kind of bridge those two worlds, those systems, technically and operationally, and then how do they come together, and then what opportunities does that then create for customers as well as vendors in the space?
Yeah. So talking about Iceberg, we're talking about table formats, we're talking about lakehouses. So one of the big features of the lakehouse was to try and sidestep some of the issues of warehousing. And one of those was the ETL process you had to do to transform your data to the schema of your warehouse. So take your raw and siloed data, it needs to be conformed to be usable and analyzed in the warehouse. But with lakehouses, with table formats like Iceberg, you get high performance analytics, and you get features such as Iceberg tables and Iceberg views. Views are kind of overlooked quite a lot, sort of virtual data sets. And if you're storing your data in Apache Parquet, you get to write your data in like a quite efficient way. So you're avoiding data bloat, With a warehouse, typically maybe every data set people would be manifesting or creating would be a physical table. Things would kind of bloat out. You kind of avoid some of this stuff thanks to Iceberg. So you've got fast analytics and things like views means you get rise to the ELT way of doing things. So you extract and load and do all your transformations in your lakehouse, which is great. Do it all in one place, which sounds perfect, right? So you're streaming your data in quickly, you're analyzing it or refining it quickly. But there's a bit of a gap, right? Like you're saying, between your topics and your tables, there's a gap, and bridging that isn't trivial, right? So if you say you've got a stream, you've got your topic, you're going to need some way of reading the data out of Kafka. So it could be like a Spark job or a sync connector. We're typically always writing stuff to Parquet for table formats. So your messages aren't in Parquet, right? You're transforming from Avro or Protobus, something like that. And then your schema evolves. One of the great things about Iceberg is that you can change your schema as you like, which is great on the one end of the solution, but breaks your pipelining if your schema starts changing between your topic and your table. So this is the kind of stuff you need to sort of deal with, and it's a bit of a headache. So this is why features like Iceberg topics are fantastic. Right, you can take away this sort of headache and are really, really useful. So now you can just stream directly into an Iceberg table. Every topic becomes a single Iceberg table, and all your schema issues get handled by the schema registry. So your metadata gets created, and if it varies, your schema changes. You don't have to worry about it, which is great. So as a customer, you don't have to. It's quite a complicated thing to do, sort of marry this sort of streaming and tables, and you can just avoid thinking about it and buy a solution that does it for you. But it's also quite great because you've got other things that need addressing. So things like file optimization, data compression, things like this, which is a problem on both ends. So various solutions such as Dremio's Open Catalog and also Iceberg Topics can also contribute and give you these features. So you have lots of solutions as a customer to solve some of the other issues that can arise, some of the headaches, some of the hassles. Which is great as a consumer.
Yeah, these things sound really simple. It's like we've talking ELT for years, getting data from A to B in its original form, and then optimizing data under the covers, which data warehouses have done sort of behind the scenes, right, over the years as well. It just hasn't been exposed as much as a user level. We like to think that we create really amazing plumbing at Redpanda, which as in real life, it really matters when it's not working. When you have plumbing issues, and people have struggled very much with these Kafka Connect syncs, in our opinion, in our experience, as well as the sprawling sort of set of custom ETL jobs that would previously move streams to tables. So having really important, efficient, non-leaky plumbing is actually quite important in people's data journey. Okay, great. So let's keep moving. We've talked about how great Iceberg is and what a great unlock it is, but we do see a more nuanced world, and I want to bring in Melvyn for this question in terms of data formats, and there may be room for specialization. So particularly ClickHouse, which is known for really speed in terms of low latency queries. So now that Iceberg has become the de facto open table format for interoperability in the lakehouse, how do you see specialized or native database storage formats like ClickHouse's native format fitting into the ecosystem? Will we see consolidation around Iceberg amongst all the database companies, data warehouse companies, or a coexistence of optimized formats for different workloads? And how do these two complement each other?
Yeah, that's actually a very provocative question I often have, when I attend like conferences and meetups, and even internally, sometimes we have this discussion about roadmap and stuff. And, we have engineers that spend years working on ClickHouse native format, and they are often asking me like, do you want to replace ClickHouse native format by Iceberg? And, I think a lot about this question because obviously this is coming up, from time to time with customers. They're like, oh, we are considering Iceberg for real-time analytics. And the way I see the world is like basically like the way I see how storage work with our customer in the field is often we see like three types of categories, right? You have like the data format that is generated by I would say, proprietary software like BigQuery, Snowflake, Splunk, with very little visibility into how to interact with this data and how to read this data. So very difficult to create a layer of interoperability. And then you have a second category, which is really about open source software, but still on top of, I would say, a proprietary format like ClickHouse or Elasticsearch, for example. And you can eventually read the code, understand how the data are written and try to interact with it, but you don't have like open specification guarantees that your engine is not going to break over time. So it's a difficult trade-off. And then now you have like these open specifications that are getting a lot of popularity, like Iceberg, Delta, Parquet, which make it possible to actually build like solid engine which will not break over time and will match, as long as they respect the specification, which make it interesting. But on the field, I see that there is some type of Pareto law where indeed like Iceberg and Delta and Parquet can match a lot of the user workload, right? They can do when, they don't have like very strong requirement or very specific requirement. But what I see, and I need to be demonstrated otherwise, is that for specific and specialized workload, like for example, real-time analytics, there is very little system that can provide the same performance that some specialized database like ClickHouse, where we spend most of our engineering effort is how can we reduce the latency, not only for query, but also for insert latency. How can we make sure that we have like a very high concurrency support for engine and having a specialized format, I think, help with this specialized workload in that sense. And as we are working, on improving our Iceberg support at ClickHouse, because for us, like being able to integrate with many formats is super important. Like I think ClickHouse is supporting over 70 different type of formats, and Iceberg now is a super important one for us, given the adoptions and given the interest that the community has around it. I try to really challenge our own engineering team and say like, how fast can we get ClickHouse on top of Iceberg table, and we'll see like if we can compete with our own native format. I have some reserve here, so I still do believe that some specialized format will still live alongside like this format like Iceberg. The way I really appreciate Iceberg is really as an interoperability platform. So having like strategic decision around your company about where all your data needs to reside. And I think it makes a lot of sense to store them into Iceberg and then have like maybe some of your tables for specialized workloads that you can put into specialized system, like for example, graph database or real-time database and so on, based on your need, and having all of this database that can actually interface with this unified format, which here in that case is Iceberg.
Yeah, that really resonates with me from the streaming world, because we're dealing with very, very small chunks of data coming in very quickly, and people want to react very fast, and they're pushing us on how quickly can we get this data into Iceberg and take an action on it, whether that's a streaming application that they built or an agent, an AI agent as well acting on this data. So it's a lot of, yes, it's generally append, but it's a lot of small appends, and actually it's not only append, because you have compaction in Kafka where you can do updates to keys, and you want to be able to reflect those updates downstream. So this is definitely an area where I think the high performance is very important, and specialized formats can help us with that for these type of workloads. We don't have a ton of time, so I want to actually keep moving unless someone is really burning to jump in and debate that point. But let's move on to this, because we have two more questions to get to in the next 7 minutes. So I'm going to move over to Steven and zoom out a bit in terms of the longer term, more fundamental impacts of all of these open standards. As a PMC member, we're working directly on evolving the technology. Do you see Iceberg and all of its various standards as the new SQL standard? We all had ANSI SQL 92, and all these different versions of SQL that kind of drove a lot of database products closer together. It created compatibility between them, application portability on top of them, and so forth. And the query engine, maybe you could argue, started to look more like each other and less differentiated in some ways. So we could see that happening here. We could see these products actually having less difference between them, or vendors differentiating in different ways. We could also see it creating a proliferation of new products, of new data platforms, because as a vendor, you see this addressable market. You see Iceberg has been adopted. It's a standard. I can build around it. There's a lot of data already written into the Iceberg format. And so we may see a lot of new companies building directly on Iceberg. What do you think the future is for this as a standard and how it affects the marketplace of vendors?
Yeah, sure. I think there are two parts to this question. I think first part is about the table format standard, right? So Iceberg is becoming the de facto standard because for data storage and access, it turns cheap, scalable blob storage to a feature-rich, high-performance transactional data layer, right? It shifts the data structure, data architecture from proprietary data warehouse to kind of open lakehouse architecture. There's no data lock-in. And with the interoperability, enterprise can use different engines or different tools for different workloads that can achieve flexibility and also cost saving. So the second part about the SQL and the engines, right? At its core, Iceberg is just a metadata system. But broadly speaking, Iceberg deals with data storage and data access. So it can help drive maybe query engines closer in those areas. For example, to standardize data access, like REST catalog, maybe a role-based access control or fine-grained access control. That Iceberg is actually working on those areas. But Iceberg is not trying to unify on one SQL flavor or solve the SQL interoperability problem. There are some other projects working on those areas, like Substrate, trying to standardize on the intermediate representation of query plans, or Cora from LinkedIn is a SQL dialect translation tool with its own intermediate representation. Yeah, actually, during the Iceberg view discussion, there's a question about should we adopt those intermediate representation for the view definition. At that time, it's a little earlier. So it'll be interesting to see how those projects progress and if they can gain wide adoption and support from the data community. Yeah.
Got it. That's really helpful. Yeah. So more of an interop unlock than consolidating all the products together and making them all look like a one. But probably also, I do think it creates an opportunity for new vendors to come in knowing they have, a standard they can work against. But that's really interesting to know. Good points. Okay, we're running short on time. So last question real quick. AI, the obligatory AI question that has to be asked in every panel, obviously. So this one can go to anybody. I'll let you jump in. With agentic AI on the rise, how does Iceberg fit into powering the next generation of agentic applications? And how does access to real-time data through something like Iceberg Topics help fuel these agents and make them more effective?
Well, I have maybe a couple of thoughts here, and especially I think it's more of a challenge, I will say. I think one of the key components for agentic AI will be around how to handle multimodal type of data. So, you have to handle images, you have to handle video, audio files, very large text. And the question will be how we will make sure that, Iceberg and Parquet support well this type of formats. We see a couple of new formats raising to try to address this concern for LensDB, Vortex, and so on. So it will be very interesting to see how actually Iceberg, which was really designed for tabular data, will adapt to this type of, I will say, new data modality that we're seeing being needed more and more.
Got it. Anybody else who wants to jump in?
Yeah, I think I definitely agree with Melvyn that Iceberg was designed for analytic workload. So this kind of ML workload is a little bit different. It's something I think as a community we should think about. Is that something we should put improve on? I think that definitely agree with Melvyn's point. But on the a real-time agentic application, Iceberg is not providing low latency data access. I think that's probably more suitable for online transaction database like Postgres. So yeah, probably you don't want to hook up your agentic application to a real-time query to Iceberg.
Yeah, that makes sense. And as you may have heard in the audience, we've announced some new technology assets to help with that problem recently in the real-time space. But I do think in the agentic space, what Melvyn said resonates in general, in that maybe not as much with the Iceberg query engine, but sort of the Lakehouse pattern, right? In general, you're going to be storing documents, images, text, all sorts of other data that's more machine readable in your Lakehouse that agents can much more easily process than a human, writing SQL. We've also seen that agents can write good SQL, actually, whether it's a very real-time agent or something that's more like a back office process that takes time, or training or other aspects of the sort of AI model lifecycle. Anybody else want to jump in on the AI question real quick before we end?
Yeah, I mean, one thing to think about is people kind of forget is that people are using AIs to just do the work they were doing before, analytics, right? So the kind of applications and the benefits of Iceberg is still applicable. You want to access all your data quickly and process it quickly. So having Iceberg gives you like a high performance foundation that you can do these kind of things. It's the basic thing that's been around for a while.
That's right. Makes a lot of sense. It's all about making us more productive. Sometimes doing the things we've been doing for ages. So I want to thank everybody because we're at time right now for the panel. Really appreciate you all joining us and working with us over these past 18 months as great partners. And best of luck out there, dodging the icebergs.